Hello and welcome back. Today I'll be going over how to factor a quadratic equation. When we have a quadratic equation in the standard form ax squared plus bx plus c, we have several possibilities that help us graph an equation. But when we have a quadratic equation, it doesn't always mean that we're going to graph something. What if we want to solve an algebraic problem? For example, we have this proportion, and we need to find the value of x, meaning that we need to factor a quadratic equation to solve this. Factoring any quadratic equation gives us the equation of x plus a multiplied by x plus b, which we briefly discussed in our introduction to quadratics. If you didn't watch that, then the factored form of a quadratic equation is simply the form in which the x-intercepts of the parabola are shown, or where the parabola intercepts the graph on the x-axis. Doing this either gives us one or two values. Now occasionally, you'll run into a graph where you have no x-intercept, and that's known as an imaginary root, but we don't have to worry about that now. There are two ways to factor a quadratic equation, in which one utilizes the quadratic formula, and the other is a simple method which I was taught a long time ago. First, I'll show you how to use the quadratic formula, as it's needed to solve much tougher quadratic equations. Then I'll show you the simpler method. For now, let's use this equation over here. Y is equal to x squared plus 6x plus 8. We can ignore the y completely and focus on the part of the equation containing the x. The quadratic formula used to factor quadratic equations is known as x is equal to negative b plus or minus the square root of b squared minus 4ac, with all of that divided by 2a. To use this formula, you have to plug in the numbers in the equation into the formula. This may sound super confusing, so let me demonstrate. Let's take the equation that we just talked about before, x squared plus 6x plus 8. The base form of a quadratic equation is ax squared plus bx plus c, and we just need our a, b, and c values. Well, our a value would be 1, our b value would be 6, and our c value would be 8. Let's plug this into the formula. Doing this gives us negative 6 plus or minus the square root of 36 minus 32 over 2. We then simplify this into negative 6 plus or minus the square root of 4 over 2, which is negative 6 plus or minus 2 divided by 2. Now, I hope you notice that we have a plus or minus symbol, meaning that we have two different outcomes. Our two situations are negative 6 plus 2 over 2 and negative 6 minus 2 over 2. Solving both of these scenarios gives us x is equal to negative 4 and x is equal to negative 2, which is our final answer. This entire method was lengthy, and there is a faster way to do this. Here's the simpler method. Write your quadratic equation out and list the factors of the a and c, which is 1, the coefficient of x squared, and 8, which is c in our case. The factors of 1 are obviously going to be 1 and 1, and for 8 we have 1, 2, 4, and 8 as the factors. Our final goal in doing this is to find a pair of numbers that when multiplied together add up to b, which would be 6 in our case. If you're confused, we basically have to multiply a pair of factors from the c value with the factors from the a value to see if they add up to the b value, which is 6. Since our a value is 1, we can just ignore it for now, as anything multiplied by 1 gives the same value. Let's group our factors into their pairs. We now have 1 and 8 and 2 and 4. Right away, we can see that 2 and 4 add up to 6, meaning that the factors that we'd be using are 2 and 4. To use these numbers, we would add them into the equation of 0 is equal to x plus 2 multiplied by x plus 4. The reason we set this equation to 0 is because an x-intercept is present at the y value of 0. Now, we need to make this equation equal 0, and we can do this by making one of the equations inside the brackets equal to 0, as anything multiplied by 0 will equal 0. Let's take x plus 2 for example. To make x plus 2 equal to 0, we would need to subtract 2 from both sides, meaning that our first x value is negative 2. We're not done yet, as we still have our x plus 4. Subtracting the 4 from both sides gives us x is equal to negative 4. Plugging either of these values into the equation gives us 0 is equal to 0, meaning that our x values are negative 4 and negative 2. Let's try another problem. Our second equation is 2x squared plus 8x plus 8, and we have to factor this equation to find our x values. Now, while we could use the quadratic formula to solve this, we can still use our simpler method. Let's start by listing our factors of the coefficient of a and the factors of our c value. Right away, you'll notice that our a value is 2, meaning that we actually have to pay attention to it this time. Our factors of 2 are 2 and 1, and our factors of 8 are 8, 4, 2, and 1. Our goal here now is to find a pair of factors that can be multiplied with the factors of our a value to give us two numbers that can be added up to 8. While this is confusing, this is exactly what we did in our last problem. We multiplied our 2 with our 1 and our 4 with our 1. Let's continue with the problem. Right away, we see that our factors can't be 8 and 1, as adding 8 and 1 itself will always be above our b value, no matter what we do, leaving us with 2 and 4. Now that we have 2 and 4, we have to see if multiplying it with 2 and 1 allows us to add the products to get 8, and luckily for us, we can. The 2 from A can be multiplied with the 2 from the C to get 4. The 1 from the A can be multiplied with the 4 from the C to get 4. Adding 4 plus 4 gives us 8, which is our b value. Now comes the issue of how we're going to express these values in the factored form. You want to group the two numbers that you didn't multiply together. This means grouping the 2 with the 4 and the 1 with the 2. We can then write our factored form equation, giving us 0 is equal to 2x plus 4 multiplied by x plus 2. We can simplify this equation. A common factor in 2x plus 4 is 2, meaning that we can just rewrite our equation as 2 multiplied by x plus 2. Since we have x plus 2 multiplied by x plus 2 now, we can just write 2 multiplied by x plus 2 squared is equal to 0. We can divide 2 on both sides to give us x plus 2 squared is equal to 0. Taking the square root of both sides gives us x plus 2 is equal to 0, and solving that gives us our final answer of x is equal to negative 2. If you have any questions, make sure to leave them in the comments, and I'll see you next time.